Hello, friends. We are back with episode 134 of the Our Weekly Highlights podcast. If you're new to the show, this is the weekly podcast where we give you all the greatest resources and happenings that have been released on the current week's Our Weekly issue at ourweekly.org. My name is Eric Nance. I'm delighted that you joined us today, new and existing listeners around the world. And I am joined by my awesome co-host, who's always the closing curly bracket to my opening bracket, Mike Thomas. Mike, how are you doing today?
I'm doing great, Eric. Tick, 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 tick. Do you hear that? You hear that sound?
I
The clock
sure do.
ticking towards PositConf?
Oh, yeah. We're if you see our commit messages on our various workshop materials, you know we're burning up here. So we're in the home stretch. But yes, it is happening less than a month from now. It's very hard to believe. But yeah, very excited. Always a little bit of nerves before that, but yeah, I'm definitely excited. And I've said it before, and I'll say it again. I'm very happy to do a one-day workshop this time.
Yes. But also, any incoherent statements we make during this podcast are likely the result of lack of sleep, trying to put the materials together. So please forgive us.
Yes. You know, we're always transparent on this show, but I think in any event, we're gonna have some nice things to talk about here because our issue this week was curated by longtime Our Weekly curator Jonathan Carroll. You'll be hearing more from him actually later in the podcast. But as always, he had tremendous help from our fellow Our Weekly team members and contributors like all of you around the world. And as much as I'd like to live in a fantasy world where everything is clean, what you expect, I mean, I really wish I was in something like this after the last meeting I had. But hey, that's another topic for another day. That's not quite the world we live in. Now, when I was doing courses in statistics at university, when we would get to actually employing the statistical methods, like say a regression model or an inference method, a lot of the data in these textbooks were very clean, very small, nothing wrong with them. Literally, they were meant for the textbook. Well, you and I both know, Mike, we're in the real world. You sometimes got to roll up your sleeves a little bit and employ some pre-processing to make a little more, usability enhancements to our data so we can get to the really important stuff, like how can these data help and the data analyses make critical business decisions or maybe feed into bigger analytical pipelines. And in the case of yours truly, using a real world type data set for our workshop that was not clean very by far. So I've been flexing these muscles a little bit recently. And in our first highlight today, Jumping River's data scientist Amiro Abrahams is a very insightful blog post on ways that you can employ best practices in the R ecosystem for your data cleaning and pre-processing operations. And she discusses three key principles that we'll touch on here. Addressing inconsistencies in your data, and boy, this can happen quite a bit. Managing outliers, perhaps that's from a data entry error or other issues, or maybe it is what the real data shows and you have to account for that. And also dealing with missing data. That's a hot topic, especially in my circles in life sciences. So when you think about data inconsistencies, a lot of times these data are not just from one set. They're often from multiple sets. And you would think if there are related variables in between these multiple sets, they would keep the same naming structure. Not always. So in the example that she outlines here in this post, there are two tables here. And for whatever reason, they have inconsistent case specification in their names. There's some that are uppercase, some that are lowercase. There may be other situations that I've seen in practice where they just use a completely different name, but it's the same content inside each of them. So there are lots of ways you can address that. She talks about, using a standard naming convention format. I often like to use lowercase names in all my variable names. And instead of having spaces, having underscores that separate them. These are things that will make it easier for you when you type your functions to, say, autocomplete as you're doing like a dplyr pipeline or just grabbing a certain variable. But more importantly, or just as important, when you bring these resources together, you're not going to have mismatches in variables that are being, binded together, say, by row. Now, throughout this, I'm going to talk about not just the tidyverse packages that are highlighted here in this post, but also some packages that are very much related to these issues that I think are very helpful to navigate these waters. And in the idea of like pre-processing for, consistency in your naming conventions and whatnot, one of the MVP packages I use in this process is called Janitor. Janitor is by Sam Frick. It has got handy functions for you to, in essence, you might say normalize or clean up these variable names that may have gone completely out of whack when you imported it from your raw data source, and also check for other anomalies as well. That is a fantastic package in your pre-processing pipeline. So I figured I'd mention that as you're thinking about how do you quickly fix these issues. And I've used Janitor quite a bit in the past in my pre-processing workflows for sure. And then we get to the idea of outliers. And again, it could be a situation where the data itself just had a very non-normal observation in that time course, for example. So what are ways that you can see those quickly? Well, I mentioned the word see here. I mean, visualization is huge in these situations. So Miro has a great example where you just do a simple scatter plot with ggplot2, and you can quickly see one of the ages is an outlier versus the score that was in this data set. And there may be methods that you have to employ differently depending on if outliers are present. So if you're doing like a modeling, maybe a basic modeling regression type setup, maybe the typical regression model that assumes normally distributed data may not be the best fit for that. You might have to look at non-parametric modeling techniques, but you may not know to look at those options unless you do an inspection of your data along the way, which is very much a fundamental pillar of exploratory data analysis. And speaking of data being not what you expect, the last principle that we'll talk about here is how you handle missing data. Now, sometimes that might mean that you have to remove that particular row or observation off the bat if they don't have data there. Maybe it's simply not going to feed into your analytical analysis or analytical method. Other times you might still use that information, but instead of using it as a missing value, you might impute it with maybe the average for that, particular observation subject or patient's, existing, measures for that variable. And then there are even some advanced, machine learning methods that can help with imputation, maybe in a more data-driven approach. Now, again, there's some great examples in the blog posts of using dplyr and mutate to replace these missing values with the appropriately named replace_NA function. And that is a terrific way to get around that very quickly. And then also, when you look at visualizing these, you might have to convert these to factor variables, especially if there are meaningful orders of groups in these variables. So using as.factor is also highlighted here in this post. And you may have to do some numeric transformations as well. But then another package, again, I would say tidyverse adjacent for handling missing data. There's actually a bunch of packages in the R ecosystem that can help with this. So much so that there is a CRAN task view that was launched about a year and a half ago on missing data approaches. And there are packages listed there like the Narnier package by Nick Tierney, which I have used in the past with great success to help both visualize and deal with missing data in many different methods. So that might be a worth a follow-up if you see this routinely in the real-world type data that you're collecting or you're analyzing for your analysis. And there are a lot of different approaches that you can take for this. So Miro talks about other ways that you can employ some machine learning methodologies that we often see for transforming data, feature engineering, and splitting your data into training and test sets, as well as mentions of advanced techniques for cleaning data in the context of, say, time series analyses and other feature engineering ideas. Some great references that are at the end of the post as well. But these are, no matter which side or what industry you're in a data analysis type role, you're bound to encounter these situations one way or another. So having a way to quickly use the tidyverse to get you up and running, and then adding in some of these additional domain-specific packages in these areas, I think can get you to that analytical stage very quickly and very efficiently. And as someone who, like I said, has just been flexing this very recently with the data sets we'll be using for our upcoming workshop, I very much appreciate the elegance of having these tools available and be able to document all of these pre-processing routines in, say, an R Markdown or Chordal document, so I can have that as reference, say, a year or two from now, and figure out what did I have to do to wrangle that messy data. So great post here, and I highly recommend checking out the links that are mentioned in the post, as well as some of the additional packages we'll have in the supplements of the show notes. So, Mike, what did you think about the great post here on data cleaning and pre-processing?
One thing that stuck out to me immediately was that this is a very tidy blog post, which I really enjoyed. Both the tidyverse pseudo package and tidy models suite of packages are leveraged in this blog post quite a bit. And Amiro didn't just give us, sort of singular options for all the different steps in the data preparation and pre-processing process. For instance, for handling missing values, she outlines how you can take one of many approaches, including removing missing values, simple imputation via the mean, the median, or using the mode. Or you can do something a little more sophisticated and impute the value using an algorithm like k-nearest neighbors or multivariate regression. So I really enjoyed sort of all the different choices and options that Amiro talked through during the blog post to walk us through her thought process, because it's very insightful to see how other folks as well think about their data preparation and pre-processing steps. I think when you are discussing that sort of topic or thinking through data pre-processing, there's a lot of different things that you want to think about. Probably at the end of the day, right? You want to create, if your goal is to build a model, the most powerful features that you can, that contain sort of the most signal. But also, if it's a process that is maybe data intensive, or you're going to use over and over and over again, if you're going to try to iterate and create many different models, you also want to think about how to write that as efficiently as possible. So one thing that's always interesting to me, and I always learn from it, is seeing others code right in this blog post, like Amiro has, that sort of point out how she thinks about putting together these data pre-processing steps. So it's nice to sort of do some peer reviewing and taking a look at how others think about it as well, and put sort of fingers on keyboard on these particular topics, which is really nice. And Amiro also provides some resources for further reading if you need to get into more advanced data preparation and pre-processing. Some of those are hands-on exploratory data analysis with R by Radhika Datar and Harish Garg, feature engineering and selection, a practical approach for predictive models by Max Kuhn and Kyle Johnson, and then feature engineering for machine learning, principles and techniques for data scientists by Alice Zhang and Amanda Kasari. So I think those are phenomenal resources if you are looking to sort of get into the next step or the next level of your feature engineering to try to create the best predictive models that you possibly can. And one more resource that I'll throw on top of that wasn't mentioned in the blog post, it's a little more recent, would be the Tidy Modeling with R book from Max Kuhn and Julia Silge, which is available online as well as in print, I believe. You can go to tmwr.org for that one. So this is a really nice holistic blog post by Amiro that she's put together for us, and I think it's a great way to kick off the highlights this week.
Rightfully so. Yeah. Like I said, I've been living this world a little bit in our workshop prep, but yeah, a lot of times, even though most of the situations at my day job, I'm literally simulating the data, so I get to control how clean it is. It's not always that way, especially when we get to other sections in life sciences where we deal with literally what we call real world analysis data, which has been used in the wild, so to speak, patients, throughout the world. And there's lots of these issues we have to deal with. So yeah, great primer to just how quickly you can get started with it. And I do appreciate the excellent references that you mentioned that have been talked about here, because you can go down a lot of different directions with this, and sometimes you have to employ even more advanced techniques, and especially in the areas of imputation. So that was really some nice eye openers for me as I think about how to handle those effectively in the future. Now, Mike, that's of course the first highlight was talking about once you have your data into your R session, the best ways to pre-process it. But sometimes it can be difficult to even get it in there, especially if the data are massive. And yeah, our second highlight does touch on that very nicely about using new USDA data with open source tools. And let me check on the author. Hey, it's you. Oh, I can't think of a better person to talk through this than the author himself. So, Mike, tell us about how Parquet helped you with this fun adventure.
Maybe this is a little our weekly highlights insider trading, but I did warn the audience last week that I had finally migrated the company's blog website from Distill to Quarto. So it was only right that we published a blog post as well that we've been working on for a little while here. And you're exactly right, Eric. It was a real world problem that we were up against that we actually couldn't find a way locally to read in this single geospatial database .gdb file from which was recently published by the U.S. Department of Agriculture on sort of crop planting, historical crop planting boundaries, if you will. And we tried to read it in using the SF package, which does handle .gdb files, and blue screen after a few different hours, just maxed out. I was watching the memory crank up. It was like over 25 gigs of memory were getting used just trying to read it in, and ended up in a blue screen. Tried to read it in with Python, GeoPandas, which does also accept .gdb files. And same issue, obviously, trying to read in the entire data set. And the SF package does have the ability to read in a single layer if you have a geospatial database file that has multiple layers. You can select the layer that you want to read in. But in this case, it was a single layer file, if you will. So we weren't able to do that. But fortunately, with some hacking, we were able to leverage the GeoPandas library in Python, which allows us to read in a set number of rows at a time. So we did that first and then decided, hey, we don't want to necessarily run into this problem again the next time we want to analyze this data. So let's try to migrate it to a file format that is a little easier to deal with and wrangle on disk as opposed to trying to do everything in memory. And that's where the handy dandy Parquet file format came into play. So we migrated the data that was published by the U.S. Department of Agriculture to Parquet file format, partitioned by year and by state, threw it up in a public AWS S3 bucket for anyone else to use and play with. And it is much, much easier to manage at this point in time. I think the entire size of the data that was published as of 2022 is 19.5 million rows, which may not sound like a lot of data, but when one of those columns is polygons, geospatial polygons that are a large, can be a large number of points that are creating a polygon or a boundary, that can get pretty heavy pretty quickly. So the fact that we have the ability now via tools like the Arrow package, the SF Arrow package, which allows you to read in Geoparquet files and handle Parquet files that have geospatial components to them. The fact that we have those packages available to us make it a lot easier to work with this type of data. So after that, we put together sort of some visuals and some tables and statistics about how we analyzed this data at Catchbrook Analytics to put together some maps to show in the state of Connecticut, for example, where different crops have been planted over time and how that has changed. And we also put together a nice interactive leaflet map, as well as some ggplot static maps to show sort of the difference between interactive versus static visuals. And then we also did some fasted ggplot bar charts as well, analyzing some other aspects of the data for some time series analysis to see sort of which crops have been most heavily planted across the state in the past 4 years. So sort of the idea of this whole project was really just to get the data in a more usable format and make it publicly accessible as well, and give folks some initial starting points that they could take a look at to try to analyze this data, because different folks may have different use cases on how this data may be available or may be useful to their organizations, depending on sort of what segment of agriculture you work in. So we fortunately got some really good feedback from some folks at the Washington State Department of Agriculture. We work heavily in agricultural finance, and we've gotten a lot of great feedback from them in terms of how they are thinking about migrating this data or leveraging this data against their loan portfolio data to take a look at trends in crop planting and how their customers, their farmers, might be changing or diversifying the different types of crops that they're planting on their farms, and how that might impact sort of some of the lending decisions that they may make. So again, this was a fun project for us to put together, a great way for us to sort of kick off our new Quarto style blog. And I hope that maybe some others or some listeners out there may find it useful.
Yeah, it's a fantastic write-up. And yeah, the Quarto site's looking clean and streamlined and absolutely, yeah, love the interface. And I feel like, as an observer, not dealing this day to day myself, with the advent of higher performant data formats and this intersection with spatial data, we're really seeing some innovations in this space that I think even just a few years ago would have just been impossible to wrangle as cleanly as what you've done here with taking that step of migrating these to Parquet. I feel like this is now a mainstream capability across so many domains in data science that I always thought geospatial or spatial was a bit slower to catch up. But boy, it seems like we're on the cusp of some really innovative ways to generate more insights on, very much higher dimension data here. And this was a fantastic way to spell out how you can get started pretty quickly. But I hope to see efforts like this, we take off even more in this community. So yeah, really excellent. Love the visuals. Love everything about it. And, you made the data public, man. Yeah, that's even better. So we can have our hand at trying this too.
It's our attempt to try to give back to the community as much as we can where possible, for all that open source has given to us. And you're exactly right that a lot of this stuff is sort of at the cutting edge. I think that the Geoparquet project itself, which is an attempt to essentially make geospatial data formatting within a Parquet file more easy for libraries like Python and R libraries to be able to recognize that data as geospatial data. I think from a compression standpoint, I think they're trying to tackle a few things there. But I think it was just a couple weeks ago that the Geoparquet project sort of released its first stable version of that project. So a lot of this stuff, you're exactly right, is on the cutting edge, and it's an exciting place to be if you're in the geospatial data science field.
Yes, and even though it's at a bit of a smaller scale, so to speak, we are going to be using similar principles in our workshop. Of part of our workshop data, we're going to put as Parquet files hosted on S3 storage, and this is becoming a lot more common than people might realize. With you may think, oh, you have to use Amazon for that. No, there are many vendors out there providing object storage and becoming much more accessible. I won't say it's for everybody, but it is a great alternative that I know from personal experience makes my Linux IT admins much happier, and we can pull from there using the state-of-the-art API packages that we have in R, Python, or other frameworks. And yeah, Parquet is a great fit for it. So in other words, get used to it, everybody. This is happening, and it's happening more routinely now.
Absolutely. The possibilities are infinite.
How do you do that, Mike? You're so good at this. Yes, that is a perfect lead in to our last highlight, which will, maybe challenge your thinking a little bit here. But Mike and I have both read through this a few times, but our curator, Jonathan Carroll, is back once again with his adventures and some really advanced programming concepts. But one that caught my attention earlier this past week when he released it is this idea of making functions that can deal with infinite sequences via generators. Now, I will admit the closest I've gotten to infinite, if you will, especially in grad school, was having this infinite desire to get done as soon as possible. But no, I digress. But it was also when you had to prove out some of these statistical theorems, you always had to prove it as like a number or a variable like n or x approaches infinity. This is what, say, the normal distribution theory does, or some other counting process theory does. But don't worry, folks, I'm not taking you to grad school on this. But what Jonathan introduces here is a couple concepts that are very much related to this. After he saw a video that was one of these Code Wars challenges that was using an infinite list. And again, this is kind of mind-boggling to me, but as we break it up in step by step, he introduces one use case where this can occur, especially in programming challenges, is coding up a Fibonacci sequence function. And for those that aren't aware, the Fibonacci sequence kind of goes like this. Your first value for an input of 0 is just 0. And then for 1, it would just be 1. But then every number thereafter, that nth number thereafter, it is the sum of the two previous values. And as I said, this could in theory go on infinitely. But Jonathan first sets up a function that does this in Haskell, which is one of the languages he's been using quite a bit in these explorations. And it's only 3 lines of code. It is super easy to set up. And you could also replicate that in R itself. And in R, what kind of blows your mind a little bit is you write this function, and then in the function, you're calling the same function again. That is recursion in a nutshell. Something I don't do as much, but I worked with people that were in the trenches on this a bit as they were doing some novel statistical algorithms. And that, again, kind of blows your mind a bit, but this is a perfectly valid approach in the R ecosystem itself. And then you may want to, instead of just returning one number at the same time or at a given time, you may want to return the whole sequence of numbers up to that point, so that you might say for the Fibonacci sequence of an n value of 10, you might want to return all the numbers that would have been like, 2, 3, 4, 5, and whatnot. And there's still a limit to that. But what if you say, you know what, I want to be greedy. I want to make that infinite. There's no way about it. Unfortunately, if you do it in a more, you might say, straightforward way, R is going to get mad at you because you can't keep going forever. You'll run into these C-stack usage errors that he talks about in the post, because this is a concept of a closure function. And apparently, the way R keeps track of its environments is it's adding what are called these stack frames in the environment every time you call it. And as it does too many of these, it's like, nope, I've had it. I'm tapping out. I'm done. Now, Haskell doesn't have a problem with this. Now, I'm still not quite sure how they approach it very clearly here, but the rest of Jonathan's post talks about there are ways in Haskell that are built in to reduce functions from a starting value in its infinite sequences, if you will. And then it gets to this concept of generators, which again is something that Python also has the notion on with iterators as well. And in essence, you can take some of the logic that Jonathan talks about in this post here and then try out to replicate this in somewhat of an R workflow. It's not perfect, but he talks about hooking into a base functionality in R to actually get the stack frames from the environments using output of sys.call, which I've never used before. This is one that's new to me as well, to, in essence, check the length of this and then appropriate enough print out the value of each x in this Fibonacci-like sequence. So you can play with this a bit, but it is pretty neat how he was able to manipulate the idea of grabbing stack traces from the environment to paste all this together. But there is one catch. This is using the global environment. This is not using like the function environment to do it. So it actually won't work in a R Markdown type file because of the way that the functions encapsulate when you execute those code chunks. So he does mention you probably don't want to do this in production, but this is probably the closest I've seen to getting these kind of generators or infinite sequences with a very well established mathematical function working in R itself. So if you have homework to do after this, it's learning about the idea of stack traces in your R environments and how you can kind of manipulate them kind of cleverly to grab then that full sequence of the function that you've defined recursively. So I don't know if I've done any better justice than I did last week in Jonathan's post, but in the event that you want to learn something new and push R to the limits of infinite sequences, John's got the code all right here, so definitely have a spin with it. But probably don't run this on your production machine learning server that's serving up a bunch of model predictions. You don't want your IT admins mad at you for breaking an R session because of this. So just your warning from your friendly friends here that do stuff in production. But in any event, great exercise to challenge your mind a bit. So you can see I was challenged a little bit, but in a good way. But Mike, what did you think about Jonathan's exploration here?
Yeah, I think one of the interesting things to me always in blog posts like this is a little bit of the etymology of different programming languages and how R compares to other programming languages. And it sounds like in its comparison to Haskell, they're somewhat similar in the idea that they're lazily evaluated. If an argument that you passed isn't used in the function, nothing happens regarding that argument. So in this blog post, you got R, you got Haskell, you got Python. So for those who are multilingual data scientists and interested in that type of thing, this is going to be a blog post for you. Honestly, Eric, my brain was pretty broken as pretty much as soon as Jonathan used a function inside of itself. I guess I still don't fully understand the reason why you would want to do that, but the fact that it's possible is wild to me. And I guess it all relates to this idea of recursion. And beyond trying to generate infinite values, like you said, Jonathan then attempts to create infinite data structures. And that's where it seems like there's some limitation in R that gets run into in terms of how big the environment can become. Maybe next week, Jonathan can author a blog post for me just on how to print "Hello World" in R. Just slow down a little bit. I'm just kidding. I think it's really interesting, sort of the rabbit holes that he dives down. It reminds me of some of those posts that used to be on our beloved, no longer beloved social media site that were like, hey, here's a little R code. Guess what the outcome of this R code is going to be? It was like a little puzzle that we would see all the time. I don't know if I've seen those on Mastodon as much, but it was always interesting to sort of see what actually came out the other side, what the actual answer was. And it's getting into some of the quirks of the R language itself, which I think is super useful for those of us on the ground writing R every day and running into some of these edge cases once in a while and getting stumped and saying, hey, interesting that R sort of works this way. I didn't necessarily understand exactly what's going on under the hood here. And it's something that I need to safeguard myself against in the future. So I think this is a super interesting deep dive. I appreciate Jonathan taking the time to walk us through sort of the different approaches across the different programming languages and a little bit of the backstory and that nice use case with the Fibonacci sequence to sort of articulate the topic here at hand with some actual tangible code.
And speaking of challenging yourself, Mike, as I see Jonathan really exploring these very, deep dives into these programming concepts, we're in the second half of the year, right? There has been, for at least a few years running now, the advent of code challenges that occur, I believe, around December or November that may benefit from approaches like this. So, if you want to get a leg up on those, fun competitions, you might want to, give Jonathan's blog a bookmark because it might prepare you for some of the challenges you might see there. So I'm very appreciative of seeing these explorations. I just don't get enough opportunities in my day job to put this through the paces. But there is one case where I am doing in essence, recursive type call in a network diagram that we want to make a lot faster. So I don't know if I have to manage more environments better or whatnot. But, this might give me a couple ideas to do some prototyping and kind of fold a little bit of John's expertise in here. But taking baby steps. So maybe John's next post is doing the hello world, but printing it infinitely. Who knows? Just saying.
Jonathan must be so good at advent of code.
I'd imagine he's in the leaderboard if he isn't already. Right, right. But do you want to be a leader in following the greatest happenings in the R community? Well, that's why you got to check out the rest of the issue that Jonathan's put together here at rwiki.org. So we're going to take a couple of minutes for some of the additional finds that are also in this issue. And I don't think I could come up with a better blog post title than this. Object of type closure can shut up. And this is from Matt Dre, who's been a frequent contributor to our weekly highlights in the past. And this post is really about when you try to name a variable or object that you create in R as the same name as a built-in function or variable. This has happened. This has happened many times. I've seen other code that does this. And Matt's got a fun example where he writes a function to kind of check what are the existing base functions that are in R, and to basically check if that function that you've named is in that list or not. So it's a fun little exercise of something that does occur quite a bit. So fun, entertaining as always approach by Matt here. So I highly recommend checking that one out. And when I see object of type closure, that relates to me also as a Shiny developer, because how many times, Mike, have you and I put that reactive outside of reactive context and we see that infamous error, and maybe it's a missing bracket too. It could happen many different ways, but that error message speaks to me in some good and not so good ways.
Yes, that one. Yeah, I feel like it's ingrained inside me in some way.
And speaking of ingrained, you've got a great find here of a new development in the space of web apps in R. What do we have here?
So we have WebR 0.2.0 has just been released. So there's some really great updates, I think, in this ecosystem. And I think we are just slowly getting closer and closer and closer to being able to host Shiny apps right in the browser via WebAssembly with that are essentially serverless. So there are actually quite a few updates to WebR between the last version and version 0.2.0. There's some changes to the WebR developer API that you may want to check on if that's something that you've been leveraging. But I think it's a very exciting space to be watching right now. So it's a great blog post to check out if you are interested in the latest and greatest in the WebR ecosystem.
And I've been really excited about this space because as part of this our consortium working group I'm under, we actually had the pleasure, our working group, to talk with the architect himself, George Stagg, about some of the latest developments. And oh boy, there's some exciting stuff here. But he, in essence, gave us his stamp of approval for the way we're approaching it to go forward with our pilot submission to the FDA using a WebR-powered Shiny app, and we are super, super excited for it. So this could not have come at a better time, and yes, I have a pretty good feeling that at the upcoming PosiConf, there's going to be even more shared in this space. So watch it closely, folks. This train is moving, and it's moving fast, but the possibilities are endless once we get to this point.
Super exciting. That's awesome to hear.
Yes, and there's a bunch of other exciting, great content in this R Weekly issue. Jonathan's done a magnificent job as always. The full gamut of great package updates, use of R in real-world settings, and yes, I do see some other great programming type exercise blog posts here as well, so to challenge your thinking there. But there's so much more where that comes from. And where can you find that? Well, as I mentioned, it's at rweekly.org. You can find the link to this week's issue right at the front page, as well as all the previous issues. And I definitely encourage you to check out the back catalog from time to time, especially for me as I see these things come through and I realize, wait, it was 2 months ago I saw that great blog post on that particular approach. I want to find that, bookmark it, and then put it into my daily work. So you'll find all those resources at R Weekly itself. And we love to hear from you and also have your contributions to the project. You can do that by sending a pull request to the R Weekly project itself. There's a direct link to the upcoming issue draft right on the home page. That little GitHub logo at the upper right, you just click that. You'll get straight to the upcoming issue draft, and you can send a PR with that link to that great blog post, new package, new video tutorial, who knows? Yep, anything that benefits the community, we want to hear it. So you can send a pull request that way, and also you can get in touch with the project itself of possibly becoming a curator by visiting the aforementioned rweekly.org and our GitHub repo. We have in the README how you can join our team. We'd love to have you. We definitely have a few openings available. And also, we'd love to hear from you in the audience. So you have a link to our contact page in the show notes of this podcast. And also, you can get in touch with us via a fun new capability in modern podcast apps called a boost, which you could do with an app like Podverse, Fountain, Cast-O-Matic. There's a whole bunch in this space. Or you can go directly to the podcast index and boost us directly from there. We'll have a link to that in these show notes as well. And also, you can get in touch with us on social media. I'm going to plug the more preferred approach first, and that is on Mastodon with @our_podcast at podcastindex.social. And that other one I'm still sporadically on with @theRcast, and fill in your favorite way to say that domain. But in any event, your best bet is to find me on Mastodon. And Mike, where can the listeners find you?
Yeah, likewise. Find me on Mastodon at Mike_Thomas at fostodon.org.
Awesome stuff. And again, congratulations on your new Chordal blog. It looks fantastic, and it was great to have that showcased here in the flesh and right here for our listeners to hear about. And maybe they're going to do some fun parquet analyses after this. Who knows?
It's not difficult to submit that pull request to R Weekly.
That's right. And we get it in every time. And yeah, speaking of insider training, we may have a familiar face be the curator next week. We'll find out one way or another. But that's going to close up shop for this week, and we will be back with another edition of our Weekly Highlights next week. So, Mike, what did you think about these data cleaning and Try again.
You're on mute, my friend.
Well, it wouldn't be a recording session. It would be fumbling through that. Okay, let me try that again. Yeah.
Is that your best?